Okay, this is a homework help for Unit 4, Worksheet 6, and I'm going to do question number 1. So for question number 1, the first thing I want to do is find my start and my stretch. So my start is going to be -2, because I want to do the opposite. And I'm not adding or subtracting anything to my y value, so f of x is the same as y. And there's nothing outside of here. So the x is being affected by 2, so that would be -2. And then y is not being affected by any shift, so that would be 0. And then to find my stretch, I look in the numerator, so my stretch is a 1. So I want to graph my start point first, so I'm going to go to where x is -2 and y is 0, and I'm going to use an open dot because that is the intersection of my asymptotes. So from here, on -2, 0, I'm going to do a dotted line going up and down. That's my vertical asymptote. And then also left and right, and that's my horizontal asymptote. Okay, so I'm going to go ahead and answer the questions to F and G right now because I just drew in my asymptotes. So for F, it asks to state the equation of our vertical asymptote. So for my vertical asymptote, that's this line right here, so the one that's going up and down. And so I look to see what axis it's crossing and at what number. So this line right here is crossing the x-axis at -2. So it's crossing the x-axis at -2. So that would be x equals -2. And then for my horizontal asymptote, I want to do the same thing. So here's my horizontal asymptote. So it's crossing the y-axis, so it's crossing the y-axis at 0. So here's my y-axis, so it's crossing the y at 0. So if I look here, my start point was -2 and 0, which are the equations for my asymptotes. So my stretch is 1. So from my start point, I'm going to go up 1 and over 1. And then I'm going to draw my curve to where I'm approaching my asymptotes and then running parallel. And I want to do the same here. And these will always be diagonal from each other from the parent function that we practice. So then I'm going to go down 1 and left 1 using this stretch as well, but just reflected. And so there's my graph. And so I want to find my x-intercept and my y-intercept. So to find the y-intercept, I want to let x equal 0. So I have my original equation. So I have y equals 1 over, and then I want to replace the value for x with 0. And then I want to solve that. So 0 plus 2 is 2. So then my y-intercept would be y equals 1/2. And then if I look at my graph, so at y equals 1/2, that's where my graph is crossing. So I have the y-axis intersecting around 1/2. And then for the x-intercept, I can kind of look at my picture here and I see that I have an asymptote here. And so my graph branches are running parallel to it. So because it's running parallel, I'm not going to ever have an x-intercept, so there would be none here. But if I didn't look at my graph and actually see that, I could try to solve. So to find the x-intercept, I let y equal 0. So again, if I didn't see that, I could go ahead and just go through the process and hopefully recognize that. So if I replaced y with 0, I would have that equation. And then to try to solve that, I would find my lowest common denominator. Which is x plus 2, because that's my only denominator. And I would multiply both sides of the equation by that. So I would multiply this equation, or the right side of the equation, by x plus 2, and then also the left side, right? So we have to try to keep our equation balanced, not our fraction. So we multiply the left side and the right side by x plus 2. And then so 0 times x plus 2 is 0. And then here the x plus 2's cancel, and I end up with 0 equals 1. And then that's not a true statement, right? 0 cannot equal 1, and my x variable disappeared, so then that would be a no solution as well. So I could see it from trying to solve it, and I can see it from looking that there is no x-intercept. Okay, so now I want to state the domain and range. So just as a reminder, our domain is left to right. So I'm going to do each branch at a time. So I'm going to look at this branch first. So for the domain, I want to know how far left the graph is going. So it has this arrow here pointed to the left, so that means it's forever going to the left, which would be negative infinity. And then as far as this branch going to the right, I know that it's like going down forever, but it doesn't get to go right forever because of the asymptote. So the asymptote is acting as a barrier, so it doesn't allow it to go anything past -2. So it can go up to -2 and not equal it, so we use that parentheses. And then now I have to do the other branch of the graph. So for the other branch, I'm doing the same thing, left comma right for domain, so left comma right. So on this branch right here, so left, so I want to know how far to the left it goes. And again, the asymptote is acting as a barrier, not allowing it to go left any further than -2. So then it goes to -2, and then to the right, so I'm going to trace it to the right, and it's going forever to the right because of that arrow tip, and so that would be positive infinity. So that would be my domain. So domain, remember, left, then right. So for my range, I want to do bottom to top, right? Bottom to top. Okay, so for my range, I'm going to start with this branch again. So bottom, so how far down does it go? And it goes down forever, so that would be negative infinity. And then how high up does this graph go? And so it looks like it wants to go up forever because it's kind of curling upwards, but it has this asymptote which acts as a barrier, right? So it doesn't get to go up forever. It's only going to go up as far as that asymptote allows it to, which is 0. So from negative infinity to the asymptote, which is 0. And then for the other branch of the graph, so for this branch, I want to do bottom comma top, so same idea. And bottom, so there's an asymptote here, which is keeping it going, down forever. So this is the barrier. And so it does not go below this asymptote, so that means 0 is the lowest it goes. And then how high does this graph go? And it has an up arrow, so it's going up forever, so that would be to positive infinity. So then my range would be from 0 to infinity on the second branch. Okay, and then let's go ahead and take a look at H. So H is saying to state the intervals in which the graph is increasing. So remember, when we do increasing, we always read the graph from left to right. Ignore the arrows, right? Ignore the arrows, and then look at the graph itself. Okay, so increasing, so I'm going to start on this graph here, and I'm going to trace. I'm going to start on the far left, and I'm going to trace. And if I look at that, I'm tracing, I'm going down. So when I'm going down, I am decreasing. So this, I'm decreasing. And then I look at this one, go from left to right. So I'm starting here, and I'm going towards the right. So tracing the graph towards the right, I'm also going downhill. So that means there is no place, right? There are no intervals where my graph is increasing because it was always decreasing. Okay. All right, and then for letter I, I'm trying to state where the function is greater than 0. So greater than 0 means where am I above the x-axis, right? I'm looking to see when am I above the x-axis. So I'm actually going to use my highlighter for this just to kind of find it easier. So if I want to be greater than 0, I want to be above the x-axis. So I'm going to jump over to my graph. So here's my x-axis, so the branch of the graph that's above it is this one right here. So that highlighted one is the one where I am above the x-axis, and so when I do this again, when I talk about intervals, I'm doing left comma right. So it's just like our domain essentially, right? Okay, so for the interval where I'm above the x-axis, so left comma right would be -2 to positive infinity. So -2 acts as a barrier, and then positive infinity goes forever to the right. Okay. All right, and then let's take a look at question number 6. So for this one here, we just want to state the equations of our horizontal and vertical asymptotes. So I know g of x is the same as y. And so the plus 5 here is what's affecting the change in my y. So I want to subtract it over to the other side. And then I want to find just my start point, right? So we don't have to actually graph everything because we're looking to just find our asymptotes. So my start, nothing is affecting the x, right? Because I'm not adding or subtracting any value on the bottom. So that would be 0. And then if I look over here, I'm subtracting 5 from the y, so this is affecting my vertical shift, and so then that would be positive 5. So my start is at 0, 5. So I don't need to graph it, but if I did graph it, I would have my start point here, which would be the intersection of my asymptotes. And so for that, then I can see, okay, so my asymptotes are x equals 0 and y equals 5, right? And I can get that straight from my start point. So x equals 0, right? And then that's my vertical. And then y equals 5 is my horizontal. Okay. All right, and then you have the extra homework page, right, the add-on, so let's take a look at one of those. So let's go ahead and take a look at question number 10. Yeah, 10. Okay, so I have this one right here. So for part A, they want me to solve the equation by graphing f and g. So I'm going to start by graphing g of x, which is 4. So I'm going to go up to 4. And then that's a special case, so that's just a horizontal line. So there's g of x is equal to 4. And then I want to go ahead and graph this one right here. So for this one, I'm going to write this off to the side just a little bit because I want to add 2 over to the other side. Okay, so I want to get that in standard form. So the -2 is not affecting the x, it's affecting my y value. And so then for my start, nothing is added or subtracted to x, so that means there's no horizontal shift, so that would be 0. And then I'm adding 2 to the y value, so that affects my vertical shift, and so then that would be -2. So my start is at 0, -2, so over 0, down 2. Put an open dot there. And then I'm going to do a dotted line left and right for my horizontal asymptote, and then a dotted line up and down for my vertical. My stretch is 3, right? So my stretch is 3. So from here, I'm going to go up 3 and over 1. And I'm going to trace going towards my asymptote. And then I'm going to reflect it and do it down here below as well. So down 3, left 1. And then go towards the asymptotes. Okay. And so if I want to see the solution, I'm looking for where they cross. So if I had to guess, so it looks like they cross right here, right? So that's where they cross, which is somewhere between, on the x-axis, between 0 and 1. So I don't know exactly, so I'm going to just say maybe around x equals 0.5. Right? Somewhere between 0 and 1. They intersect, so between 0 and 1. So now I want to solve it algebraically. So I'm going to take the equation 3x minus, or 3 over x minus 2, and then equal it to 4. And then I want to solve that equation algebraically. So I'm going to add 2 over to the other side first. And then I want to look for my lowest common denominator. So the only denominator I have is x, so that's got to be my lowest common denominator. And then I want to multiply both sides by x. So then x over x would cancel. I'm left with just 3. And then 6 times x is 6x. And then to isolate the variable, I'm going to divide both sides by 6. So x equals 3 over 6, but I know I can reduce that, so I can divide by 3 to the top and the bottom. So 3 divided by 3 is 1, and then 6 divided by 3 is 2. So it looks like x equals 1/2. So I got pretty lucky there on my guess. Okay, so what's the relationship between my answers in part A and part B? Well, algebraically, I know x equals 1/2. I wasn't guessing, I actually solved for it. But when I graphed it, I had to kind of guess and eyeball where I thought the solution was. So the relationship is the intersection of the graphs. Is the solution to the equation I solved. Okay, and that's it for the homework help.